China has truly redefined modern engineering by constructing the world's largest train station atop a massive mountain peak, showcasing.
This is a train station, the world's largest, built in 38 months, on a mountain. 2 million cubic meters of concrete, 366,000 tons of steel, 40,000 workers. Most countries take longer than 38 months to approve a planning application. China built this.
41 meters tall, shaped like the city tree of Chongqing, covered in 1,200 stainless steel scales.
Before the first column, workers cut an entire mountain flat. The station never sat on flat land. Grand Central, 6 times smaller. Europe's largest, 15 times smaller. Over 400 meters per platform. The trains here are longer than the Eiffel Tower is tall.
The project faced deadly cliffs, rocky mountains, freezing weather, and dangerous terrain. Engineers had to dig massive tunnels through
like a mountain slope, 20 kilometers from Chongqing city center, the 8D city. Roads above your head, trains through apartment blocks. This is where they chose to build it. A train through a building, normal in Chongqing. That tells you everything about the city that built Chongqing East.
They continue to carve through these towering mountains and build giant bridges over deep valleys, creating new pathways for travel and trade across the entire region.
April 2022. The machines moved in. Step 1. Cut a mountain flat. Every meter of slope mapped in 3D before a single cut was made. The earthwork alone took months. The rock under Chongqing is hard. The machines ran around the clock. Some sections needed blasting, controlled explosions. The mountain didn't give up its rock easily.
One of the largest single-site excavations in Chinese construction history. Millions of cubic meters removed, all of it for a flat platform.
Once cut, the cut face had to be held, retaining walls along the full perimeter. The mountain wants its space back. Every drop falling on the mountain above flows through to the site. Without drainage, the foundation sits on saturated ground. Excavation, blasting, retaining walls, drainage, a flat platform on a mountain. Now the real construction begins. Before the first pile, the ground is tested. No assumptions on a mountain site. The site preparation is done. The mountain is flat. The drainage is in. The ground is tested. Now, the foundation piles through the surface into bedrock. Every floor, every ton, transfers its load through these piles into the mountain. Hundreds of piles, multiple rigs working simultaneously. The foundation is not one pile, it's a forest. Rebar cage before concrete. Without it, the pile has only compressive strength. Half what's needed. Concrete poured bottom up through a tremie pipe. Pour from the top, the aggregate sinks, the pile is weak. Every pile load tested. A failure here, far cheaper to fix than under a completed building.
20 meters into bedrock, I can see 30 centimeters of it. The other 19 meters 70 are underground or invisible, carrying everything.
Hundreds of pile heads across 1.22 million square meters. The entire foundation, invisible below the surface. Pile caps distribute the column load across multiple piles. One column doesn't rest on one pile, it rests on a group. Ground beams tie every pile cap together. One load anywhere on site, shared across the entire grid. The first floor slab, formwork, rebar, concrete, repeated 8 times to get to the top. 40 degrees. Workers tying rebar by hand in full protective gear, every floor, every pore. In this heat, concrete generates heat as it cures. In Chongqing summer, it can crack from within. Cooling pipes prevent that. One continuous pour, stopping creates a cold joint, which is a structural weakness. Trucks arriving without pores. The 41-meter columns you see in the finished station began here, on the ground floor. One pour at a time.
Rebar cage, formwork, concrete, cure, strip, repeat. 41 meters of that went in, one section at a time.
Five floors complete. Platform levels, metro below, bus and taxi. Now 3 more on top. The 6th floor, the main concourse, the largest single space. Being built 30 meters above the mountain slope. The concourse edges curve. If the slab edge is wrong, the glass wall won't fit. Every curve hand-formed. 7th and 8th floors, retail, restaurants, city layer on top of transport layer. Same construction, repeated. The 8th floor, last concrete slab. After this, the steel columns begin. 8 floors complete, open to the sky. The roof hasn't started, but the structure is there. The 41-meter columns begin at 8th floor level, rising into the open above the concrete frame. 366,000 tons of steel arriving by road, sorted by crane, ready to go up. The first steel section above the concrete, growing toward a roof that doesn't exist yet.
6 to 8 meters per section, one at a time. Bolted, plumb checked, then the next. 41 meters of that.
Every splice torqued to the same specification. A column section carrying 16,500 tons of roof. Every bolt matters. 40,000 workers don't do one column at a time. The entire forest grew together, cranes at every position simultaneously. The branching arms, where the column becomes the Huangjue tree. More connection points to the roof. Better load distribution. Scale fitting from the bottom while sections crane in at the top. 2 operations on the same column simultaneously. 3 millimeters thick, 1,200 per column. Each fitted by hand. Bare steel versus finished column. Same object. One is what engineers built, the other what architects designed. Scale workers at 5 meters, 20 meters, 35 meters, all on the same column simultaneously. All columns standing, branching tops ready. The forest of steel before anything covers it. Every column head verified. Receiver plate off by a fraction. The truss won't sit. No adjustment once it's in the air.
41 meters from base plate to column top. 1,200 hand-fitted scales. And the roof hasn't started yet.
8 floors of concrete, 41-meter columns, no roof yet. This is the most dramatic construction stage, the skeleton before the skin. The roof is assembled on the ground. You can't build 16,500 tons section by section at 57 meters. Build it here, then move it up. Every bolt torqued to spec, marked complete. One under-torqued bolt in a 16,500 ton roof, unacceptable. The rail runs at column head height. Roof raised once, then slid horizontally. Built on the ground. Raised once, moved to the sky. Multiple cranes rising to 57 meters. Workers guiding by hand signal. Millimeter tolerance on the rail landing. Rehearsed for weeks before the first real lift. Hydraulic jacks, 10 meters, 20 meters, into position. Moving hundreds of tons of roof like furniture. The weld. When it cools, that section of roof belongs to the building permanently.
Hundreds of tons moving on rails above me pace, because no crane could lift it directly. The engineers invented the method for this building.
Section by section, lifted, slid, welded. 120,000 square meters piece by piece. Workers on the roof at 57 meters, the Chongqing Mountains in every direction. Fitting the stainless steel that becomes the building's skin. Skylights cut after the panels go on. Each ellipse precisely located. 120,000 square meters. The largest single-span roof structure in China, 16,500 tons. Now, the building is covered. What happens next happens inside. 1,200 tons of aluminium framing before a single glass panel. 800 kilograms per panel. Workers at height in 40-degree heat. Hundreds of separate lifts. The glass wall closes the building. The mountain landscape floods in. The design was always about this. The glass reaches 60 degrees in summer, below 0 in winter. Expansion joints absorb that movement. Without them, it cracks. While 8 floors rose above, crews tunneled toward the site from the metro network below. 2 projects, 1 building, 30 meters below the concourse, built underground while the floors above went up.
Metro underground, 30 meters down, 1 escalator to the high-speed platforms. That connection is why this hub works.
The escalators connecting the deepest level to the busiest. Every metro passenger will use these. The track base before the rails, level to millimeter accuracy. At 350 kilometers per hour, it must be perfect. No ballast. Slab track bolted direct to concrete. Once in, it doesn't move, settle, or need tamping. Millimeter alignment on 29 tracks. Inside a building on a mountain slope. Every meter laser checked before fixing. Thermite welding, 1 continuous rail, no joints inside the station. Catenary at exactly the right height. Too high, pantograph loses contact. Too low, it's damaged. Wire tension changes with temperature. The system compensates automatically. Workers calibrate for Chongqing's full temperature range. Every screen door must align with the train door. The train's stopping accuracy was designed around these positions. 1.22 million square meters of floor, the size of 170 football pitches. Consistent spacing, every tile identical. The machine achieves what no human crew could. Without HVAC, The concourse is a greenhouse in Chongqing summer, sized for the hottest day on record. Thousands of kilometers of cable through every floor, corridor, platform. This building runs its own substation. Fire suppression across 1.22 million square meters. The sprinkler network is larger than the roads of some small towns. The LEDs dim to minimum when daylight floods in. Safety requires base lighting at all times. At dawn and dusk, they compensate seamlessly. Tracks being tested while shelves are stocked.
Nobody sees this. The service corridor. HVAC ducts as wide as a car, electrical conduit for hundreds of meters, installed before the walls closed.
Before a test train, the geometry is measured. Every deviation corrected before the next stage. Every signal tested individually, then in combination. No conflicting movements can be authorized. After every run, a corrections list. Normal, fix, retest, repeat. The list reaches 0, 200 kilometers per hour on approach. Everything tested at walking speed, now retested at 20 times that, under real load. Every failure mode tested before one passenger boards. Not because it's likely, because it cannot be left untested. 38 months. And still the snag list. Every imperfection corrected before handover. The last act of construction. June 27, 2025. Blueprint to operating station. 38 months. Opening day. The concourse full. The flow working. The escalators running. The trains departing. An airport desk inside a train station. Your bag goes to the airport. You board a train. Live for the first time. 8 floors, everyone working, every mode connected, all running for the first time. After the last train, cruise on 29 tracks, every night. At 350 kilometers per hour, maintenance is not optional.
The columns, the roof, the tracks, the metro, the glass wall. Every construction challenge POW, working right now.
3 months in, 16,000 passengers per hour, running exactly as modeled. 1,200 scales per column, each at a different angle. The column changes all day. That was designed. The cranes that built the station moved to build the district around it. Station first, city follows. 38 months ago, this was a mountain slope. Passengers don't think about that. They just know this is where the train stops. 6 months in, every connection checked. The conclusion? Better than the most optimistic projections. 1.22 million square meters, 8 floors, 41-meter tree columns, 16,500-ton roof, built on a mountain slope in Chongqing. In 38 months, 120,000 square meters of roof. Skylights bringing in the Chongqing sky.
Piles into bedrock, 8 floors, columns, roof slid into position, metro tunneled in, opening exactly on time. That is Chongqing East.
Metro underground to high-speed concourse. 1 escalator. Tunneled in while 8 floors were built above it. 57 meters from floor to roof. 8 floors connecting an entire city. 40,000 workers, 38 months. Passengers don't think about that. That's exactly right. Blueprint, April 2022. Opening, June 27, 2025. 38 months. The world's largest train station. On a mountain, in Chongqing. Welcome to Chongqing East.